Hi, I'm Josh Caplan, and I lead product management for OneLake at Microsoft. OneLake comes as part of Microsoft Fabric. Fabric accelerates data potential for the era of AI. Fabric provides a unified intelligent data foundation for all analytic workloads and integrates Power BI, Data Factory, and the next generation of Synapse to offer customers a price, performant, and easy-to-manage modern analytics solution. As you will see, every analytics workload works seamlessly with OneLake to minimize data management time and effort by eliminating data movement and duplication. When we started working on Fabric, we spoke to a lot of customers to better understand the investments that they were making in data lake strategies. What we found is that customers had these visions of these pristine data lakes, which provided one place for an organization to land all their data. Having it together in one place would break down data silos, making it easier to blend and analyze together. Having everything in one place would simplify the management, governance, and discovery of the data, making it possible for all users and applications to access the data they need. Getting to this reality, however, was difficult. Analytics with data lakes was a lot like file sharing prior to OneDrive. If you remember back to those days, you would buy servers, set up folders, put ACLs on those folders, and you would use that to share files. It worked, but you had to build the file sharing solution. Services like OneDrive came along, changing the game by giving you a SaaS service for sharing files. Instead of buying data lakes, you buy storage. You build your own data lake solutions on top of that. This isn't easy. Building one pristine data lake has its own challenges, which require a lot of coordination through a central team. The popular data mesh pattern pushes business groups to manage their own lakes so that they can work independently, but this comes with a lot of overhead. No matter which path you take, the results almost always end up being the same. You end up with multiple siloed lakes for different business domains. Then you need to build solutions for breaking down those silos. This usually involves moving the data. Even after moving the data, most users and applications are not able to access the data lakes directly. So you build data marts, data warehouses, cubes, Power BI datasets, all to serve the data. And these don't just reference the data in the lake, these are copies of the data. And sometimes they're copies of the copies of the data. Before you know it, you have data flying all over the place. However, you build complex solutions to manage all these activities because of the value you're able to get from the data itself. OneLake aims to provide you a data lake as a service without you needing to build it yourself. For years, you've had OneDrive for all your documents. Now, you have OneLake for all your data. Let's look at how OneLake does this by going through these concepts. Starting with OneLake itself, OneLake provides you a single data lake for your entire organization. For every Fabric tenant, you'll always have exactly one OneLake, never two, never zero. There is no infrastructure to manage or set up. The concept of a tenant is a unique benefit of a SaaS service. It allows us to automatically provide a single management and governance boundary for the entire organization, which is ultimately under the control of a tenant admin. The admin sets the initial boundary, and any data which lands in OneLake will automatically take part in out-of-the-box data governance, such as lineage, data protection, certification, catalog integration, and much more. All data is ultimately under the control of a tenant admin. However, it is important that different business groups can work independently without going through a central gatekeeper. Just as an Office user does not need to coordinate with their admin to create a new Teams channel or a SharePoint site, OneLake enables similar distributed ownership through workspaces. Different workspaces allow different parts of the organization to work independently while still contributing to the same data lake. Each workspace can have its own administrator, access control, region, and capacity for billing. Creating a workspace is very lightweight. It inherits the rules set by the tenant admin, so there is no need to re-implement the same governance or spend time trying to get different resources to talk to each other. Workspace admins can further control access to the data within their workspace as needed. You might be thinking that your organization can't have just one lake because you are in multiple countries and you have requirements that data must reside within those countries. OneLake covers this by spanning the globe as well. Different workspaces can reside in different regions. This means that any data stored in those workspaces will also reside in those countries. OneLake is built on top of Azure Data Lake Storage Gen 2. Under the covers, it will use multiple storage accounts in different regions. However, OneLake will virtualize them into one logical lake. Let's zoom into a couple of these workspaces and see how the data is being stored. In OneLake, all data comes as part of a Fabric data item. And Fabric data items are pre-wired to store their data in OneLake using open file formats. What is a Fabric data item? If you currently use Power BI, you will already be familiar with one data item, Power BI datasets. Fabric brings several new data items, each with a tailored experience for different personas. For example, a fully transactional data warehouse for T-SQL developers, and a lakehouse for data engineers. The lakehouse provides the most lake-like experience for anyone used to working with storage today, but it also provides so much more. No matter which item you start with, they will all store their data in OneLake, similar to how Word, Excel, and PowerPoint save documents in OneDrive. When looking at OneLake directly, you're not going to see data items and workspaces. You will see files and folders, just like you would in current data lake solutions. Any tabular data will be stored in Delta Lake Parquet format. We are not creating any new proprietary file formats for Fabric. Proprietary formats create data silos. Even our SQL data warehouse will natively store its data in Delta Lake Parquet format. While Fabric data items will standardize on Delta Parquet for tabular data, OneLake is still a data lake built on top of ADLS Gen 2. It will support any file type, structured or unstructured. How the data is stored is important because OneLake is not just a Fabric data lake or a Microsoft data lake. It is an open data lake. In addition to being built on ADLS Gen 2, OneLake supports the same ADLS Gen 2 DFS APIs and SDKs, making it compatible with existing ADLS applications, including Azure Databricks and Azure HD Insights. Tenants will appear as one big storage account, with different workspaces appearing as different containers and data organized into folders. The underlying physical storage is virtualized away. OneLake ensures proper scale and performance. If you've worked with ADLS APIs, addressing data in OneLake should look familiar. There is no need to remember storage accounts as there is just one virtual account for all OneLake. Workspace name goes into the container portion of the URL, while the item name and type are all part of the path to the data. Let's look at a demo of OneLake in action.
In Fabric, I'm able to see all my existing workspaces, and I can even create new ones if I need to, since creating workspaces is very lightweight. I'll select an existing one. In this workspace, I can see different Fabric data items, including this data warehouse. Opening the data warehouse, I can see that I have one table in one schema. Now, since OneLake is the OneDrive for data, just like OneDrive, I can explore all my workspaces and all my data directly in Windows. Here I can see the data warehouse that I'm in right now. Opening that up, I can see a folder for tables, the schema, and one table inside. I'll go ahead and create a new table using T-SQL and load a row of data into it. Refreshing the folder in Windows shows the new table. And opening that new table shows the Delta log and the Parquet data inside. Even though I created the table using T-SQL, all the data is stored in open formats in OneLake. The lakehouse is the most lake-like data item in Fabric. While the data warehouse is fully transactional, which allows me to load data using T-SQL, the lakehouse lets me load data using any means, and it also lets me load semi-structured and unstructured data. In this case, I have some images I want to train an ML model with. These images are sitting locally on my machine. Let's go into the lakehouse I just created. In the Files section, I simply copy and paste the images from my machine into the lakehouse. In seconds, I see these files now available in OneLake in my lakehouse. Now I've built a data pipeline in Databricks that I've been using to build my data lake. I want to have this data stored within my new lakehouse. Through OneLake's open access, I can do this very easily. I find the path to my lakehouse by clicking on it and hitting Properties. I copy the ABFS path from the Properties window. Going into my Databricks notebook, I can see that I'm reading data from a storage account, doing some transformations, then writing the data back to another storage account in the Delta Lake format. I'll just replace the path here to my storage account with the path to my lakehouse. I can see that the lakehouse path includes the workspace name, as well as the lakehouse name and its data item type. I'll just run the notebook, and that's it. All I had to do to adjust this notebook to load data to a Fabric lakehouse was change that path. Going back to the lakehouse, I see these tables now available with data inside them. I can continue with my data journey. With OneLake, there are no data silos. Data is stored in open formats, and with open access, I can work with my data using familiar tools and services.
Let's bring in Adi to talk about how OneLake more efficiently enables the data mesh pattern.
Thank you, Josh. As we've seen, OneLake allows breaking down data silos within your organization, and it actually enables defining and implementing a data mesh pattern. But now we're taking it one step further. We're introducing domains as an integral part of the experience to provide a true data mesh as a service. So what is a domain? A domain is a way to logically group together data within the organization that is relevant to a specific area or field. For instance, imagine defining a domain for your marketing data, for your finance data, and for your sales data. Those domains are defined with domain admins, who could then add description and configure that domain forward, and also with contributors, both of which can associate workspaces to that domain, thus allowing grouping together relevant data to your business. In addition, true federated governance can be achieved by delegating settings from the tenant level to the domain level, thus allowing domain admins to achieve more granular control over their business area. Business optimized consumption is provided as well, as domains simplify discovery and consumption of data across the organization, as users can filter per domain and discover data in that way. And last, data swamps can be avoided by endorsing certain data within a domain and tagging that data as certified as or promoted, thus surfacing that data to the top and encouraging reuse. Let's see a live demo of these capabilities, showing how to define domains, how to associate workspaces to them, how to achieve federated governance, and business optimized consumption. Domains in OneLake allow easily following a data mesh pattern, structuring your data according to business needs, allowing federated governance and business optimized consumption. Here's how it works. To define domains, let's open the admin portal. A new entry has been added for domains. Let's enter it. In the domain screen, I can see all the domains defined for this organization, their administrators, and I can edit or delete them. Now let's see how I create a new domain. In this case, I'll create a finance domain for our finance department. I'll add name and description. I'll select an image for this domain and brand it to later help users understand the context they are in across their data consumption experiences. I'll define domain admins, allowing more granular controls from tenant to domain level. And I can also define domain contributors, meaning who can associate workspaces to this domain. It can be set to the entire organization, limited to specific security groups, or controlled only by tenant and domain admins. I'll keep it for the entire organization. Now let's move on to assign workspaces to this domain. I can assign single or multiple workspaces to the domain, either by name, by workspace or security group, or by selecting workspaces according to the capacity they are associated to. In this case, I'll assign by name, searching for terms of interest, then selecting all relevant workspaces and easily assigning them at once. Returning to the domain screen, I can see centrally all workspaces which have been assigned to finance. To allow federated governance, we will soon introduce the ability to delegate settings from tenant to domain level, allowing domain admins granular control per their business needs. For example, export to Excel is set as enabled for the entire organization. However, in the finance domain, I'll choose to block the export capability. Now that we've seen how domains can be defined and managed, let's see how consumers can gain from more optimized discovery and consumption experiences. For example, on the OneLake Data Hub, I can filter by domain, which will adjust branding to convey the business context I am in, and filter the data I can discover to items relevant to my current business needs. In a nutshell, you've seen in this walkthrough how domains can be easily defined, associated, managed, and consumed in Fabric, allowing organizations to structure their data to business needs, thus providing a true data mesh as a service.
Moving on to OneCopy. Today you are forced to copy data across lakes and clouds to break down data silos. You are forced to copy data out of the lake itself into different data engines to serve the data to users and applications. OneLake with one copy aims to get the most value possible out of a single copy of data without data movement or duplication. Let's go back and look at our different domains in OneLake. A large organization will typically have lots of data domains with different data owners. If we zoom out, we can see all these domains in OneLake. To get a 360-degree view of your business, a single data item will need to span multiple domains. It is shortcuts that provide the connections between domains so that data can be virtualized into a single data product without data movement, data duplication, or changing the ownership of the data. Let's zoom back in and look at how. A shortcut is nothing more than a symbolic link which points from one data location to another. Just like you can create shortcuts in Windows or Linux, the data will appear in the shortcut location as if it were physically there. Previously, if you have tables in a data warehouse, which you want to make available alongside other tables or files in a lakehouse, you would need to copy that data out of the warehouse. With OneLake, you simply create a shortcut in the lakehouse pointing to the warehouse. The data will appear in your lakehouse as if you had physically copied it. Since you didn't copy it, when data is updated in the warehouse, changes are automatically reflected in the lakehouse. You can also use shortcuts to consolidate data across workspaces and domains without changing the ownership of the data. In this example, the workspace B still owns the data. They still have ultimate control over who can access it and how it stays up to date. Many of you already have existing data lakes stored in AWS Gen 2 or Amazon S3 buckets. These lakes can continue to exist and be managed externally to Fabric. We have extended shortcuts to include lakes outside of OneLake and even outside of Azure so they can all be virtualized into OneLake. All data is mapped to the same unified namespace and can be accessed using the same AWS Gen 2 APIs even when it's coming from S3. So far, we've only been talking about storage. It is compute that powers all the analytical experiences in Fabric. In Fabric, the compute is completely separate from storage. Separation of compute and storage is not an entirely new concept, but Fabric does not just give one multi-purpose compute engine for all analytics. Rather, Fabric provides multiple compute engines which can all access the same copy of data without needing to import it into another copy. This means you will always be able to use the best engine for the job that you're trying to do. Let's look at an example. You have a team of SQL engineers building a fully transactional data warehouse. They can use the T-SQL engine and all the power of T-SQL to create tables, transform, and load data. If a data scientist wanted to make use of that data, previously they would have to use a connector which goes through the SQL engine, or they would copy the data out of SQL into the lake. But with Fabric, the T-SQL engine is natively storing the data in OneLake in Delta Parquet format. This means that data scientists can use the full power of Spark and open source libraries to read the data directly from the data warehouse in OneLake. Same for business users trying to view reports in Power BI. Power BI reports use the analysis services engine to query data. This engine has been able to connect the data in two ways: importing the data and then loading it into memory. This requires you to maintain a copy of that imported data. The other way is to directly query the data from the source, which doesn't have an extra copy to maintain. However, direct query can be slow without the in-memory cache. With the new direct lake mode, the analysis services engine can read the Delta Parquet files into memory without making another copy, combining the best of import and direct query. If your data engineering teams are more oriented to Spark rather than SQL, they can use the full power of Spark and notebooks to transform and load data into the lakehouse. The T-SQL engine can still be used to create views and serve data to business analysts running SQL queries. Business users can view their Power BI reports using the same copy of data with direct lake mode in the analysis services engine. When defining the data strategy for your organization, you no longer need to optimize for different teams with different skill sets and preferences. Teams that want to work with SQL can work with SQL. Teams that want to work with Spark can work with Spark. Everyone builds the same data lake. There are no silos. With open access for OneLake, the same is even true for teams using engines outside of Fabric. Your data engineering team could use Databricks notebooks and use the AWS DFS APIs to land the data directly in the lakehouse. They could also create shortcuts to existing AWS Gen 2 or S3 accounts built through Databricks to virtualize the data into the lakehouse. All engines would still work over the same copy of data. We are doing a lot of work to optimize our engines to work directly with Delta Parquet as their native format for tabular data, as you've seen with the T-SQL engine for data warehousing and Direct Lake mode for analysis services for BI. Let's look at a quick demo of shortcuts and OneCopy.
Several teams in my organization are responsible for different sets of data. These data sets reside in OneLake, other places in Azure, and even in other clouds. To get a 360-degree view of our business with a common data mesh, I need to combine data across these different domains. Normally, this would involve lots of data movement, but with OneLake, I can use shortcuts to just reference the data and build one logical lake without making another copy. One of these business domains in my organization has prepared some centrally managed and certified data as part of a lakehouse in OneLake. To reuse that data, I'm going to add a new shortcut, which will allow me to create a reference to that data right inside my lakehouse. I select OneLake, and I see all the lakehouses I have access to. I pick the certified one that contains the order table I need. That table immediately appears in my lakehouse as if I had copied it, but because no data has been duplicated, and I'm just referencing the original table, I will always have the most up-to-date data available. For teams who are storing data in Amazon S3, we can do the same thing. Let's go back to shortcut creation. I can link to data even outside of OneLake, including Azure Data Lake Storage and Amazon S3. Here's the second set of data I need. This data is stored in Amazon S3 in Delta Parquet format. I copy the path to the customer dataset. When creating my shortcut, I select S3 as the source, provide some connection info, select the data location, and that's it. Just like before, the customer table automatically appears in my lakehouse without the data ever needing to leave S3. Using shortcuts, my lakehouse now contains the order table from Microsoft OneLake, the customer dataset from Amazon S3, and using another shortcut I created ahead of time, the product dataset from Azure Data Lake Storage. With OneLake's one-copy approach, the same data can be accessed by multiple compute engines, regardless of whether the data is stored natively in OneLake or logically available through shortcuts. A data scientist can train their models directly over this data using a Spark notebook. Here we can see a query running on those three datasets. Data warehouse professionals can query and analyze that same data joining across those three datasets. And business analysts can simply navigate to the modeling view and start developing their data model. They can create rich BI reports immediately with great performance using Direct Lake. With OneLake, I can easily organize my company's data into a single unified logical lake, with one copy of data that can be used across domains and projects and by multiple compute engines. OneLake empowers data engineers, data scientists, as well as SQL and BI analysts to all collaborate in a common data mesh on the same copy of data without any data movement or duplication.
Moving on to OneSecurity, I'm going to give you a peek at where we're going with securing your data in OneLake. We are in active development of the first phase of a feature we are calling OneSecurity. Its goal is to let you secure the data once and use it anywhere. OneSecurity will bring a shared universal security model, which you will define in OneLake. These security definitions will live alongside the data itself. This is an important detail. Security will live with the data rather than living downstream in the serving or presentation layers. To do this, OneLake will need to provide the necessary security features at the lake itself to support a wide range of analytic scenarios. More granular data security can be defined on a data item once in OneLake. This will include table, column, and row level security. In this example, I have defined security on a data warehouse. That security will flow across any shortcuts which reference that data and be enforced by all engines, including when analysts and engineers access data using T-SQL, data engineers and data scientists use Spark, business users view reports in Power BI, and even in non-Fabric engines using the ADLS DFS API. Stay tuned to the Fabric blog for more details on the OneSecurity roadmap. Now let's go back to Adi one last time to talk about the OneLake Data Hub.
OneLake Data Hub is the central location within Fabric to discover, manage, and reuse data. It serves all users from data engineer to business user Data can easily be discovered by its domain, for example, finance, HR, or sales, so users find what actually matters to them. It allows efficient data discovery using advanced search, filter, and sort. And it also allows exploring by hierarchy of workspaces, so data can be easily discovered. Once you've selected an item of interest, DataHub also allows a deep dive into details, exploring and reusing related items. You can access the detail page and then see metadata relevant to the item, such as description, endorsement, sensitivity label. It also shows you all of the related items, both downstream and upstream, that are using that item and that are easily accessible. And that all is to allow and encourage reuse. Various actions are available for that item. For instance, data preview, exploration, analyzing in Excel, creating a report on top of that data artifact. All of those can easily be done even by non-technical users. And last, it also allows you to understand how the data flows in Fabric. You can access the lineage view and perform lineage and impact analysis to assess potential impact of upcoming changes. The Data Hub is consistent and pervasive across your organization. That very same discovery experience is consistent across all of Fabric and is available everywhere users need to discover data. That way, it allows data reuse across your organization, as well as showing in-context capabilities of Data Hub in the various flows. For instance, that very same Data Hub is leveraged as a compact view when creating a shortcut in OneLake, when getting data in a data flow, when connecting to a KQL database, when creating a data set, and when attaching a notebook to Lakehouse. All of those and more are leveraging the very same OneLake Data Hub to allow users to discover data everywhere. And that very same OneLake Data Hub is also the bridge to Office and to discovering OneLake data there. It is available today in Microsoft Teams. And again, it targets both technical and non-technical users for data discovery, reuse, and exploration. Let's get a glimpse of the OneLake Data Hub in a live demo. Here are all of the goodies coming to you. The OneLake Data Hub is the central location in Fabric to discover, manage, and reuse data. You can discover data relevant to your business domain, explore its metadata and lineage, gain insights, and take action. Let's have a look. In this case, I filtered to HR data, and now finance data, allowing business optimized consumption and enabling a data mesh paradigm. I can view recommended items or navigate by workspace and explore properties such as type, owner, and sensitivity. Viewing endorsed in my org allows discovering curated data which is certified and serves as sources of truth. And I can also filter according to data item types, such as dataset, lakehouse, warehouse, or other. Let's filter to lakehouse, and then navigate to a workspace of interest. Next, I'm selecting Demo Lake, and I can dive into its details, viewing all the related items which are using this lakehouse, and take further action. Let's track lineage for Demo Lake by opening its lineage view. I can see the relevant notebooks and pipelines connected to it, as well as explore its impact analysis and view impacted items across all workspaces. Next, let's open the Lakehouse editor. Here I can, among others, create a new shortcut to the data in the lake. When getting data, I'll select OneLake. The very same Data Hub experience will appear in a compact mode to ensure consistency and completeness when exploring data across Fabric. Again, I can filter by business domain or item type, select an item, and then proceed with the shortcut creation. The very same OneLake Data Hub is also available in the widely spread Power Query Online. In this case, I'll open the data flow editor. Clicking on Get Data, users can either use connections to external sources such as Excel or connect to existing data using the OneLake Data Hub. To see more information, I can click on the dedicated tab, browse data items and details as previously shown, and select an item to connect and get data from. Last, the OneLake Data Hub is not only available within Fabric or in other hosted experiences. It is also the way to discover and explore data within Office. Here we have moved to Teams, and once again the Data Hub is available, providing a lens to all your Fabric data across all item types, allowing exploration by properties or business domain, gaining insights, and taking action. This concludes our overview session of OneLake and how OneLake along with OneLake Data Hub can help you break down data silos in your organization. On behalf of Josh, myself, and the Microsoft team, thank you for spending your time with us. We hope you found it educating and valuable to your organization.